Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to all viewers. Hope all of you are stay safe. On behalf of the committee, we would like to extend a very warm welcome to distinguished lecture series. I can say we have a lucky number because this is the 90th series under the Faculty of Engineering, University Technology Malaysia 2020. This is the lecture series among industry and academia in sharing of the knowledge, ideas, and application, especially regarding the latest issues that link with our industry. Transformation of construction towards the current wave of digitalization seems a vital among construction players, and it is a need for us having a good process and planning which incites this emerging as the main catalyzer. Acceptance construction in technology, especially in the whole supply chain towards the revolution on people, process, and technology, especially on the application of BIM, AR advancements towards safety requires transformation by a proper planning and strategies. Therefore, it is an honor and a great pleasure for me to introduce our guest of lecture series, Professor Dr. Shang-Hsien, Hsieh, or known as Prof. Patrick, the chairman of the Department of Civil Engineering, National Taiwan University, and our coordinator of the series, Professor Dato Engineer Dr. Muhammad Rafiq bin Dato Abdul Kadir, the Dean of Faculty of Engineering, UTM. Today, Prof will bring a very interesting topic and very much related to our Construction 4.0 strategic plan, which just launched last 2 weeks, in the title of The Application of BIM, AR and AI for construction quality, productivity, and safety. Without further ado, I would like to pass over to our beloved Dean, Professor Dr. Engineer Dr. Muhammad Rafiq bin Dato Abdul Kadir to introduce our honored speaker, Prof. Patrick. Over to you, Dato.
Thank you, Izzah. Assalamualaikum warahmatullahi wabarakatuh. Welcome everyone to our 90th UTM Engineering Distinguished Lecture Series. My name is Muhammad Rafiq and I am the Dean of Engineering, University Technology Malaysia. Today, it is my utmost pleasure to welcome Professor Patrick Shang-Hsien from National Taiwan University. A bit about our distinguished speaker today. Dr. Hsieh is a professor in the Computer-Aided Engineering Division of Department of Civil Engineering at National Taiwan University, NTU, Taipei. He is currently serving as Chairman of Department of Civil Engineering in NTU and Director of the Research Center for Building and Infrastructure Information Modeling and Management in the department. He is a member of Board of Directors of the International Society for Computing in Civil and Building Engineering since 1999 and served as the Society's president from 2006 to 2008. He has a wide range of research interests, including engineering and construction simulations, engineering information and knowledge management systems, innovative engineering education, parallel and distributed engineering computing, earthquake engineering, and structured dynamics and object-oriented software development. Dr. Hsieh received his BS in Civil Engineering in 1985 from NTU and his MS and PhD in Civil and Environmental Engineering from Cornell University, USA in 1990 and 1993, respectively. From 1993 to 1995, he worked as a postdoc research associate in the School of Civil Engineering at Purdue University, USA. He joined the Department of Civil Engineering at NTU in 1995 and had since served as the Chief of Extracurricular Activities Section in the Office of Student Affairs, Vice Chairman of Department of Civil Engineering, and Deputy Dean for Office of International Affairs. So that is a brief biography of our distinguished speaker. Here now is Professor Patrick Shang-Hsien from National Taiwan University with a talk entitled Application of BIM, AR, and AI for Construction Quality, Productivity, and Safety. Professor Shang-Hsien, over to you.
Yeah, thank you. Thank you, Dean Rapid's introduction. Let me share my screen so you can see my PowerPoint. Okay, I hope everybody can see my PowerPoint right now.
Yes, Prof, we can see your PowerPoint.
Oh, great, great. Okay, so
and you can click hide. There is a StreamYard button there. You can click hide.
Okay.
No.
You mean the voice or?
Yeah. Okay.
Is that better?
Okay. Thank you.
Okay. Yeah. Okay. So as Dean Rafik just introduced, I set the talk on application of BIM, AR, and AI for construction quality, productivity, and safety. So I'm not going to go into too much technical detail, but I would just like to share with you the application, how this technology can be applied to improve our current construction activities. So this is a brief outline of my talk. Basically, I am going to divide my talk into two parts. The first one is a BIM-based AR application for construction quality inspection. So this one is the combination or integration of BIM and AR application for construction quality. And then the second part, I will shift the focus to vision-based construction site monitoring with AI for productivity and safety. There have been many literatures that you can find in recent years related to these two topics. But I will just use our own experiences, that the research that we have conducted at National Taiwan University to share with you our views and experiences on the BIM, AI application to construction industry. So if you want to get more technical details, of course, you can follow the reference to dig out the paper. This is a paper we published last year in the 4th International Conference on Civil and Building Engineering Informatics held in Sendai, Japan. So this is not online. At that time, we were still okay to have the face-to-face conference. So the motivation for this research is as follows, that we all know that quality control is an important process performed by general contractors. But in traditional quality control scenarios, inspectors use design drawings, this paper-based mainly, tape measures and cameras to perform on-site quality inspections. This is not very efficient. So we are thinking that there must be a better way with the current new technologies that we can help the quality inspectors to do a more efficient and better job. So the solution we propose in this research is to integrate BIM and AR technologies. We all know BIM provides detailed information of the building. Usually that was prepared or provided by 2D design drawing in traditional way. But now we have this 3D digital model that can help us to understand the space that we are constructing much better. And then AR, augmented reality, this technology has been available for a long time. But I think a lot of young people know about this technology more in the games they have been playing. This technology provides visualization for comparing, in this research, for comparing BIM model components and the real object. So these are the basic quality or characteristics that we use from these two technologies. And so in this research, we try to build a smart quality inspector system. So I would, in the following slides, I would try to show you how we can integrate these two technologies and to help the quality inspectors to do a better job. So the first thing is I will try to quickly describe the system. So the system has one part that is on portable devices like iPad, or cell phone. So for example, here we just use the cell phone, mobile phone as an example. And then on this mobile phone, the inspector will carry this. That's basically the thing that he needs mainly. And then on the mobile phone application, then we can handle images, and then also right now the mobile phone also can help us to get the location information. And then of course we need the 3D BIM model, and so we need to import and transform the BIM model into the mobile devices. And we cannot just use the original BIM model in the modeling software because it's too heavy. So in this case, we try to convert that into a lighter weight model. And then on the server side, we also build a system for the managers, so they can once the information got uploaded into the server through the web into the database, and then the manager can look into the information collected by the inspector. So this is the mobile device that we prototype. We use the Android system, but you can also use the iOS system, iPhone, that would be fine. And then we use the Unity 3D framework to export BIM model from the PC to portable device. So Unity, this is a platform that is commonly used by the games. So it's kind of a game engine. It provides very nice 3D capability for us to manipulate the 3D model. And then inspector, since we already have the model in the mobile device, so now we can overlay the model on the real object, just like what you can see here. We have this model, and then through the camera's lens, then you can see the real space, and then we can overlay the model on the real object shown on screen. And then inspector can compare this and then make comments. So you can take a photo and then attach a description on the photo as a record. And then they can upload this record to the web server. Either if the construction site already have the Wi-Fi, they can just do it right away, or they can store those information on the mobile device and then upload the information later on when they return to their office. So this is just just show you more clearly that you can see the overlay of the model and also the real object. And then there's a flow control. This is just for you to quickly jump from one flow to another to manipulate through inside the digital model. And then we also show you the flow map, so you can know about the current position on the flow. And then there's some photo control for you to lock. Sometimes because for convenience, once you already overlay perfectly the model, the BIM model and the real object, and you can lock it so it won't get shaky. And then there are some menus here for different functionalities that you can play with the model, you can take the photo, you can set some features of the map, and you can even, if it's not easy for you to type the text, and then you can just use the recorder to record the information, and then that all this will be associated with the photo that you are taking. And so this one is for model control. For example, you can, I'm sorry, these are in Chinese, but I will try to explain that to you. This is for the transparencies of the model. So a lot of time you want to adjust the transparencies of the model so you can overlay the model in the real object pattern and also see through the model. And then you can turn on and off the floor, the wall, or columns, or the ceilings, and some decorations. So you can turn it on and off. And then you can also adjust some the moving speed of some control. And then you can also set some rotating angles. And then, as I mentioned, that you have another set of tools on the administrative side, so for the managers. So this is just a web-based interface for the manager to see all the information and data. So another thing that we try is when we are taking the photos, since we overlay the images and the model, and so we can back calculate the position we are in the digital model, and also we know the location in the real side, and so we know how to, then we can back calculate how to map the photo onto the surface of 3D digital model. So for example, I'm taking all these photos on the left-hand side, and then as long as we know the pose of the camera and also the position in the digital model, and then we can back map the photo onto the surface of the digital model. So the part remaining green means we don't have any photo on that part of surface. But for the rest, these are the photos already attached onto the BIM model. In this way, then we have a better way to put all the information together and relate to the one-to-one mapping between the real object and the digital twin. And then we try to test the tool into a real construction project. So this is the project, but we only, at that time, it was under construction. So we only used the B1 to the second floor, the BIM model to do the test. And so, for example, we can check the size of the opening. So then we can identify if the door position and its size is correct. Of course, if you find out that there is a large discrepancy, then we still need to use a traditional way to do the measurement and to make sure what's the discrepancy in terms of size. But we basically can just use this to quickly take a photo and mark it and then ask for correction. So the reason for having this tool is that one day a site manager told to me that he said he usually have a very good idea of where to look for problems in the construction job site. But a lot of time, the problem pop up in those places he didn't expect. But it's very difficult for an inspector to be able to pay attention to those things that he was originally not intending to check. So it's better that if there's a way that we can do a more thorough checking and through this kind of photo taking, then that can help them a lot. So that's why we get into this kind of research. And then you can also check the location of the embedded pipes. Although the pipe has not been installed, but you can overlay the BIM model and onto the job site and then try to check if the locations are right. So just a quick summary for this part. In this research, a small quality inspector system is proposed and prototyped and we take advantage of both the BIM and AR technologies. And I think it's obvious through the presentation, you can see when this technology is compared with the traditional quality inspection, then it's much more convenient, and the inspector should be able to inspect a larger area and with a reasonable time frame. And it's much easier to comprehend a 3D AR model than 2D design drawings. This will provide a more efficient way of identifying the discrepancies between the design and actual construction. Okay, now I'm going to move into my second part of talk. This one is on visual-based construction site monitoring with AI for productivity and safety. So I will quickly go through one paper that we published in the 20th International Conference on Construction Application of Virtual Reality. Unfortunately, this one was held online in late September and early October due to the COVID-19 pandemic. And then I will show you another research that we have recently finished and already submitted the paper to automation in construction on temporal image analytics for abnormal construction activity identification. This one is for construction productivity issues. And then I will show you some recent works that we haven't published, but those are on the construction safety. So I think the motivation for vision-based monitoring is that nowadays we have a lot of tools that can help us to take videos from the construction job site, either through UAV or our camera, or right now even some robotics. They can carry the camera, and it's easy to get those video streams. But real-time monitoring, we know that can help effective construction project management. But right now, there's still not a good way for us to process those recorded video. So a lot of construction contractors, they have collected a lot of videos, but still rely a lot of manpower to go through those videos. So I think with the current advancement of AI, deep learning technologies, we feel that we should investigate how the current AI technology can help us to process those video stream and then identify things that we would like to identify. Okay. So we will talk about the computer vision techniques for construction site monitoring, and then I will talk a little bit about the deep learning based methods that can help us for automatic monitoring. So first, about the literature review. So before we start the research, we started from reviewing the literature on the application of computer vision techniques for construction site monitoring and management. And then we try to look into the research hotspot and authors' collaborations to understand better the progress and community building in this field. And then we try to highlight the evolution of the research and to indicate popular deep learning model used for various computer vision techniques. So the expected contribution from this literature review is that we found that early reviews are mostly related to specific application, such as construction safety. And the latest one was published considering data till March 2019. And the review of the recent applications of computer vision techniques and deep learning model for automatic construction site monitoring is our major target for this review. And so the methodology that we use is include bibliometric and scientometric analysis. So the first thing is that we use the keyword to search from the Web of Science code collections to get a number of papers. And then we only select papers published in English. And then we go through the papers and try to identify those unrelated to computer vision and construction site monitoring, and then we remove those. And then we perform the analysis to find check the keyword co-occurrence to identify the research hotspot, and also try to identify the current authors' collaboration, and try to do some universe collaboration analysis and country collaboration analysis. I will show you the result. And through the content analysis, we try to identify the methodology, the research into three major categories. One is about the construction applications on the productivity, safety, and monitoring. And then there are some computer vision applications. So this is more on the, before we can apply those computer vision techniques to the construction, then we have to do some research on computer vision and their applications. So that involves object detection, object tracking, pose estimation, and action recognition. I will explain this further later. And then there are algorithms and models for deep learning, the AI part. And for this one, we need to prepare the data set or select the data set. And then we need to select the model and then train the model, and then we can apply the model to real application. So from the publication statistics, in the 92 SCI index journal papers that we retrieved, we found that 61 are relevant for review. And you can see that more than half published in recent 2+ years, starting from like 2018. And then in terms of journal publication, you can see most of these papers are published in Automation in Construction. And the second one is Journal of Computing in Civil Engineering. And the third one, the Advanced Engineering Informatics. And then if you look at the keyword co-occurrence map, then we can see that the research hotspots are computer vision, deep learning, construction workers, and tracking. And deep learning and machine learning are the two most recent keywords in the field. And from the author collaboration analysis, and also looking at the research organizations, you can see these 4 organizations have more paper published, and also these are the citations. So you can see that the paper published from Hong Kong, in China, they have more number of paper published. And then the second group are from US, that's University of Illinois and University of Michigan. Although they have fewer paper published, but they attract a lot of citations. And then, as I mentioned, the computer vision techniques related research, we call that preparatory work before we can apply those techniques to the construction. And then the paper working on the construction applications, we call them applications here. And you can see 84% of the papers are on this category. And then we have 16% on the preparatory work research. And you can see that construction safety and construction productivity are the top two applications right now from the literature. And then for the deep learning AI applications on the image processing, you can see the model used for object detection and their applications, and then for object tracking, for pose estimation and action recognitions. So let me, I will explain why we have this kind of application of techniques, but I'm not going to go into the details of all these models. I just try to show you that, and you can easily find out similar results from the literature spread, that what model has been mostly used for what type of applications. So this is what this table shows. For the same application, people may try different deep learning models, and they all get different kind of results. Some are better in one application, but may not be better for all other applications. So a lot of times the research, you have to try different models, and even the different combinations of the models. Okay, so this is just a quick summary for literature review. Most of the paper related to deep learning and machine learning have been published very recently, starting from 2018. And then US and China are the most productive countries for paper publication in this field. And about 85% of articles are on the computer vision applications. And then we classify them into 6 types of applications. And then different deep learning approaches or models have been sort of identified as a popular approach for different computer vision applications, like faster RCNN for object detection, SALT for object tracking, stack Huggins network for pose estimation, and 3D CNN for activity recognition. We also found out that advanced research efforts are still needed for vision occlusion, background clutter, congestion, low illumination, multi-camera, multi-object tracking, and the imitation of the public available data set for the construction project. Now I will move on to another research that we have done recently. This one is that we try to see if we can identify the activities from the data stream or video stream that from the construction job site, and then try to analyze those video stream, and then we can identify abnormal activities. And because abnormal activities, it may affect productivity and workers' safety. So we would like to identify or develop an approach that will be able to automatically identify some potential abnormal activity on the construction job site. So that's the basic idea. So the first thing is that, for example, in the photo here, you can see that if we want to monitor this kind of earth moving activity, so the first thing is we have to detect the machineries first, and then that's the first thing. Once we detect them, then we also, because they are moving, so they have the action. So we also need to track the objects on the construction job site, and then we also need to identify that these two machines are working on the same activity. They are kind of a group. So this kind of relationship identification. So that's why we need to go through object detection, object tracking, and then action recognition to identify if that action is the one that I would like to monitor. And then once we have that, and then we need to find a way to do operational or productivity analysis. So, for example, like for this one, okay. And then we also need to track the pulse, so that we know that what's the current action of that particular machinery, and that will be related to the activity items that we would like to monitor. And then we also need to find out the relationship between, for example, the truck and then with the excavator. And then there's another technique that we use is called the crew balance chart. And we use this line chart form. So here are the activities. And then this is the timeline. So then through the videos that we recorded, and then we need to identify what kind of activities is going on with one particular object that we identify, say the truck or the excavator. And then the time duration for that action, and then they may shift to another one and another one. So this is called a line chart. So this is for analysis of the action of the object. And once we have that, and then we can use some statistical approach to analyze the productivity. Say, for example, the time for each activity or number of cycles and so on to perform productivity analysis. So this is the example that we use in the paper. So we have the excavator and the truck, and so the excavator is operating regularly, but then here the truck was fully filled, so it moves away, and then a second truck comes in for the excavator to fill the truck again. But then here in the 500 second, and then somehow the activity stopped for a certain period of time. Okay, so those are the analysis. So through this kind of analysis, then we can identify if there is an abnormal activity. So I just quickly show you one example in the paper. So we use the data set provided by Roberts and Gopal. For all this kind of research, we need to first get a good quality video or photos or a video stream. And then the researchers need to label all the images to identify the object and even label the activity. And so we got 10 videos. They are 2 to 10 minutes video. And all the video have one excavator and up to 2 dump trucks. And then we need to do action annotation. But it's very nice that Roberts and Gopal have already done the annotations and the tagging for us. That's why it's convenient. And then we also use the Alberta construction image data set. For those, we can split the images to train our AI model, the deep learning model, for them to be able to identify the object, the excavator or the truck. Okay. And so we train the model, and then you can see the accuracy after about 5,000 iteration to 10,000, and then you reach about more than 90% or 95% of accuracy. And so then we can apply this model for the object identification. And then we need to do the equipment tracking. So we compared 3 different deep learning models to track the equipment's motion. And then we also need to recognize actions. So then, of course, we also need to label the images to let the deep learning model to learn, to train the deep learning model. And later on, they can help us to identify which action the machine is performing. And then we try to convert those automatic recognized actions into this line chart form of the CDC. And then you will get this cool balance chart like this. So the upper part is for the excavator, the lower part is for the truck. Okay. And then we need to apply some statistic approach. Here we are trying to use 2 approaches to test it. One is called Gaussian distribution. Another one is called box plot. And so we get 10 videos from the Earth moving operation data set, and 7 videos as these statistical samples without irregular operation, and 3 videos for testing. Those are with irregular operations. And so we can see that, as I mentioned, that during this operation, and then one truck was fully filled, and then so it moved away, and then another one comes in. So that's why the excavator stopped action. But this is not abnormal. This is just a truck exchange. So this is okay. But on the second part here, then you have irregular cycles, and the truck is still here. So then we need to identify why, what kind of accidents or what kind of situations that make the excavator stop their action. So another way is try to identify the abnormal activities through the box plot. So kind of setting a range of the box to check if some activity stop for too long, this kind of, and then we will flag red. If say we see in some reasonable time frame, and also we identify that there's another truck coming in, then we know that it's just a truck exchange. So we won't flag that as abnormal activities. But anyway, at the end of the analysis, then we can produce something like this for the manager. So we can say, okay, this is a total operation durations, but for the second one, then we identify some irregular cycle, but this is for the truck exchange that we kind of identify. But there's another one that we are not quite sure what happened. And then we show the manager the time in the video, and so they can quickly jump into the segment of the video to visually identify what's going on over there that affect the productivity. And then there are many other applications that we have been trying for our contractors to identify potential construction safety issues. So right now, as I mentioned, for this kind of object detection technique, computer vision technique, that we can identify if a person have wear the protective equipment or not. So for the green box, that means it's okay, it's fine. But for the red one, then that means the workers are not wear the protective equipment according to the requirement. Okay. And then there have been some research to identify the unsafe behaviors. So this one we need to identify the pose of the worker, and then try to let the job site manager knows that some worker may need to be trained so they can avoid the injury during their work. And then another one that we are currently trying is for the hazard zone detection. But this one, right now, we are trying a simpler approach. That in the construction job site, a lot of time they will use this red cone to identify the restricting area or hazard area, and so people should not get across this red, this surrounding line into the area. For example, there have been some crane operations, and then anything on the area underneath the crane operation, people should be avoided to get into that zone. So right now we are trying to see how we can try to identify the cone, and then through automatically identify the zone, and then if there's someone getting into the zone, and then we can set forth a warning. So that's the research we are currently working with some contractor right now. Okay, that's all for my talk. I hope we still have some time for some discussions. Let me just stop the sharing of the screen.
All right. Thank you so much, Prof.
Yeah.
Thank you. Thank you very much, Prof, for the interesting sharing. Very fresh, very new. So let us proceed with a question and answer session. Okay, so Prof, from Prof, Associate Professor Dr. Tan. Okay, Dr. Tan said, dear Prof, thank you for the sharing. I have a question regarding to the BIM application for real-time inspection inside a building under construction. When the inspector bring the device and enter the building, how do the device, smartphone or iPad, identify its location, altitude, orientation to match with BIM model inside a building where GPS is weak? So usually smartphone or iPad are also unable to identify. So Prof, maybe do you have solutions?
Sure. This is a very good question.
Thank you.
Usually we don't have the GPS inside. So there are many different type of approaches, but in the construction job site usually is quite unique, because a lot of time even we do not have the electricity on the job site, so it's even difficult for people to set up the Wi-Fi, right? So a lot of time we can use the Wi-Fi station to do localization. But usually it's not that easy. But here it comes the nice thing about the BIM model. Because we have the BIM model already know the orientation, right? So we just use the BIM model to overlay with the construction job site. And then we can back calculate our position in the BIM model. And the BIM model have all the information about north, south, east, and even the flow. But for flow, of course, it's sometimes difficult, but it's very, very easy for human being to identify the flow. So that's why if you see it, in the example I show, we actually have a bar on the left-hand side of the device that we can just quickly move from flow to flow, because it's easier for human being to identify the flow than using any sensing device to identify which flow you are on. So those are the things that you can apply for build the localization inside a building. But if you have the electricity, I think in the future it would be much easier to implement like a beacon approach. That means right now you can the beacon is made smaller and smaller. Probably in the future, in any of the light tube, we can order the light tube with beacon, right? And then you can have many beacons, and then you don't need to use battery for those beacons because they are connected to the electricity directly. And then through this dense beacon, and there's another way that we can do the indoor localization much easier. So there are many different ways of doing this. Yeah.
All right. Thank you. Thank
Yeah.
you, Prof. Maybe second question? Is there any second question? Maybe, Prof, while waiting for the questions, actually how the governance Taiwan bring this construction, I can say, industrial revolution way forward for Taiwan. I mean, how the government plays their role.
For the construction job site, I think right now the government is putting more effort in recent years on the construction safety. So right now, they have already developed a system and also library of objects for the construction, for the contractor to use BIM model to evaluate the safety issues before the construction starts. So they need to use, so for the force work and what kind of force work and what kind of safety measure they need to apply during the construction. And when they submit their work proposal, then they need to use the BIM model to do some analysis, job site hazard analysis through BIM model. And the government provide a set of library for you to quickly place those objects or components into your BIM model. So this is an ongoing work by the government-sponsored research. So they have been working on this for 2 years and have already got some useful tools for the contractor to try. Yeah.
Okay. So it's like hierarchy. They have to submit the hierarchy before for the proposal. Mm-hmm.
Yeah, because usually you just submit a written proposal for the job hazard analysis, right? But right now the government say, no, I want to discuss the proposal with you through 3D. Simulation analysis. Yeah.
Oh, that's good. Is there a question? Sorry. Okay. All right. Thank you. We have second question. Okay. Thank you, Tayaba. I have a question that in engineering field, mostly researchers use input-output model and I think price model. What is the reason behind this? Maybe, Prof?
I'm not quite sure if I understand your question correctly, but I think this is the most simplest model that we can use. Any system need to receive some input, right? And once they receive the input, it can be a command or some kind of message or some information for them to process. And then we want this system to produce something that we call output. So, or you can look at backwards, say, okay, well, we want some system to give us some output, but then we need to feed the system with some input. And then we need to connect the input with the output. So that I think that's the simplest model, and it's just a very engineering mind, I think. We try to simplify things into a very simple model. Yeah.
All right. Thank you, Dr. Tan. So how is the BIM application in Taiwan? An example scenario in Singapore where the builders submit BIM to authority as to fulfill requirement, but yet still using traditional way. I mean, like printing out drawings for actual construction process. So how BIM implementation in Taiwan?
Yeah, it has been many years in some local government, for example, most advanced one is the new Taipei City government and also Taipei City government. They require, they right now do not enforce all the project to do this. But for public construction project, they require people to submit the model for reviewing for the building, for getting the building permit. So there have been some automatic code checking for building permit application in these two local government. Right now, they are trying to push this further. Starting from next year, I think they are trying to push this further to include more public project to go through this process. And then there in some research that I also participated in, try to see if we can, how to carry out the model we receive during that building permit application process. Those models are in IFC, and then how can we utilize those models further to ensure the quality of the construction and also collect sufficient information for operation and maintenance. So there have been some research work and some pilot projects going on right now in Taiwan for this. Yeah. And general BIM applications, I think, in Taiwan are similar to other countries. We have this A-class designer and contractor that can do BIM very well, but still there is a large majority they are still trying to catching up to use BIM technologies. So yeah, I think we are just doing, I would say we are doing fine here in Taiwan in terms of BIM application.
So any scoring impacts for those that submit BIM? I mean, is there any initiative from the government for those that implement BIM so far?
Yeah, I think the government would like to create some incentives for people going through that line of application. So, for example, to accelerate the application process for building a permit, for example. So that would be the benefit for going through that. But I think eventually, if we are talking about going into so-called smart city, BIM model would be just the necessary digital infrastructure that we have, the government have to work out. So it's better that through the very beginning that we try to collect those information instead of after construction, and then you have to come back to build a model. It would be much difficult and more costly.
Agreed. Prof, we have one more question from Dr. Chai Chang Saa. All right. Thank you, Dr. Chang. Dr. Chai, so good to see you again. I have a question regarding the cycle time measurement for the productivity output. For instance, the IMU might not be cost effective for automated measurement. So what is your suggestion? Thank you, Dr. Chai.
Well, right now, I think there will be different kinds of approaches. In the future, if we are talking about manless vehicles, right? So automatic operated machinery. And then, of course, there will be a lot of monitoring or control devices on those machines. And then we can just talk to those devices and get the information or signal from those devices to identify the activities or the cycle time. And that's one way. But right now, it seems to us that there is another way to go through computer vision. And then, so that's the current approach. Of course, I think in the future, if you can put some kind of devices on the machine and to collect the information. That's another solution, definitely. Yeah.
Alright, thank you. So, do we have any more questions? I guess so. Thank you so much, Prof.
Yeah.
I guess this is the final part. I can
Yeah.
say that we would like to wrap up. Thanks
Okay.
again,
Yeah. Thank
Prof,
you.
for a very good sharing. So to conclude and wrapping up the session, I can say that it is a very good insight for the sharing based on the current technology. And now we would like to invite back Datuk Rafiq for the session.
Yeah.
Thank you, Iza, for moderating this particular session, and thank you for inviting Patrick to this
Thank you.
distinguished lecture series. And to our distinguished speaker today, Patrick, thank you so very
Yeah.
much.
Thank you,
First, for
Prof.
Thank you.
accepting our
Thank you for
invitation,
invitation.
and for a great sharing session. And to all of you watching this webinar, UTM Engineering Distinguished Lecture Series, thank you very much for watching. Do stay tuned because we have many more interesting lectures for you. Until next time, bye-bye for now. Bye-bye.
Yeah.
Thank
Bye-bye.
you. Bye bye.
Bye-bye. Bye-bye. Yeah.